Hey everyone, welcome back. I am Neeraj. Let's continue our journey of object-oriented programming in Go. In last few sessions, we implemented inheritance and encapsulation. In this session, we will implement polymorphism in Go. Before diving into actual implementation, let us first understand very quickly about the word polymorphism. In simple words, the word polymorphism refers to have multiple forms. That means one entity, one type can take multiple forms. That would be very much clear about our by looking at our struct. We are developing a software for a product store where many employees are working. Some people are salesperson, some are managers, some may be accountant, and so on. We had already created a few structures for our employee. We created an employee struct that is acting as a base class. We created salesperson struct and a manager. We embedded employee struct inside the salesperson, and we also embedded employee struct in the manager. Both of these employees, obviously, they are not working for free, so they are getting paid. But they are getting paid a little differently. All the employees will be paid with this formula, like salary minus taxes. So whatever the tax slab the employee is falling, the salary would be different from the basic salary. Maybe a salesperson would fall under the tax slab of the 10%, and a manager would fall under the tax slab of 20%. So actually, all of this employee are employee, but the way that their salary is getting computed, that is different. So that means that one employee type that is acting differently based upon the whatever the underlying asset is. If it's a salesperson, the salary computation is different. If it's a manager, the salary computation is different. This is what we are going to implement in this application. So very quickly, we will add a few fields. We will add salary. Type would be float 64. And for a manager also, we will add a salary field. That would also be type float 64. And next, we will add a few struct functions. But before doing so, we will create an interface because polymorphism is achieved with the help of interface. So we will say type employee interface. We will have one single function to display the salary of an employee. Let's call it display salary. This function is not going to take any parameter and not returning anything. If you are familiar with Java, Go's interface is not too different. In interface, we simply define the name of the function and its signature without the function body. So we will implement this display salary function upon our employee. Actually, salesperson struct and the manager. Very quickly, we will say func ef type salesperson, and the name would be display salary. Not going to take any parameter, not returning anything. And we will very simply calculate the tax e dot salary times 10 divided by 100. This way we will calculate the tax, and now we will very simply format and display the employee salary after the tax. We will say fmt dot printf. Name would be, it would be a string, and salary would be float. And we also add slash in for a new line character, and we will say e dot name and e dot salary minus obviously, so we need to subtract the tax from the basic salary. Okay, and very quickly we will copy this whole function, and we will implement the same for the manager as well. And we will simply replace it salesperson with the manager, and the tax would be the manager falls under the 20% tax slab. Okay, we have created the struct functions, and now let's move to our main function, and we will create a few employees, and we will display the salaries of the employees. Also, just a quick recap what we have done so far. We have created an employee interface with a function display salary, and we created a struct function display salary upon salesperson struct as well as on the manager. Go's interface is such a beautiful thing that it says whatever functions I am having, I mean, I am referring to the interface with the same signature. If any struct that is going to have the same function what an interface is having with the same signature as defined in the interface, that means that struct will be of that interface type as well. That is why, since our salesperson struct is going to have a display salary function as defined in the exactly as defined in the employee interface, that means the salesperson will also be a type of employee interface, and also our manager would also be a type of interface as well. Okay, this thing will help a lot to create a slice of employees with a different types. Very shortly we are going to see that. Okay, let's move to our main function, and we will create few employees. We will get right of this. So first I'll start with the salesperson. We will also create a few more employees. So this time I'm going to create a manager. So we will see manager 1. I better also call it salesperson 1. And we will replace the salesperson with the manager. The name would be manager 1. And the basic salary for a manager would be, let's say, 20,000. So we have created 2 employees. And now we will create a slice where we will store all of these employees. So we will create a variable employees. I'll use the make function. We will create a slice of model.employee, not employee, rather employee interface. The initial size would be 0, and we will add this employees to to this employees list. Better also call it employee list. We will use append function, append salesperson 1 and also manager 1. Okay, our program looks to be okay. So very quickly, so try to format and see. Let's try to run it. So say go run main.go. So we are getting 2 employees, the salesperson having a salary of 10,000 and a manager having a salary of 20,000. Next, we will iterate through this employee list, and we will display the salary of the employee. For EMP, I'll use range to employee list, and we will say EMP dot display salary. Let's see that. Also comment this format statement. We will say again go on main.go. So we are getting the salary appropriately. The salesperson we set the basic salary as a 10,000, and the 10% is a tax, because the salesperson falls under 10% tax slab. So that's why we are getting the salary of 9,000. And for a manager, we are getting the salary appropriately. So 20,000, the 20% is a tax. So that's why we are getting it appropriately. Okay, here we are doing something interesting. First, we created a slice of employee interface. And next, we added our salesperson type and a manager type into the employee list slice. But the question is, how did we do that? Well, salesperson is a type of salesperson, and the manager 1 is a type of manager. So these are the 2 different types, but still we are able to add into the slice of employee interface type. Reason is very, very simple, just because of interface. Go's interface is very, very powerful and very interesting. And actually, I must say, if you want to be a good Go developer, one must have a good hands-on on Go interfaces. They are super, super powerful. Because many professionally written application, written code, you will get a lot of use of interfaces. I have also created a session a few months ago on interfaces. I'll provide the link in the I button. You can have a look at that. That may be useful. If you want more explanation on Go interfaces, do let me know in the comment section. I'll surely create a new session on Go interfaces for sure. That's all for now. I'll see you next. Till then, take care and happy coding.